Hello, this lesson is about solving systems of equations graphically. So, first of all, a system is a collection of equations. The equations have all been collected by a bracket. Okay, so in the system, all the equations have been collected like this by a bracket. That's how you know it's a system. And when we're solving them, one of the ways to do it is graphically. When you're solving graphically, you need to change the equations into y equals mx plus b. You need to, in other words, solve for y. Okay, and then after you have the equations in the correct format, in slope-intercept form, you've solved for y, then you can graph. You want to either graph it by putting it in your calculator or by graphing it by hand. So either way, and you're going to go ahead and draw that graph. Then, after you've drawn it, the place where the lines cross is the solution. When you solve graphically, one of three things could happen. When you solve a system graphically, the first thing that could happen is that you have an independent system. That means that you have exactly one solution. If the two equations are independent, there will be just one solution. Now, how you can tell that there will be exactly one solution is if the equations have different slopes. Here you can see it has a slope of 3, here it has a slope of 5. If the slopes are different, then there'll be just one solution. So you have to look, what you have to look for here is different slopes. Alright, and so one solution means that you're going to have two lines that intersect with exactly one solution. Alright, if the equations are dependent. If they are dependent, then there are going to be infinitely many solutions. If they're dependent, that means that when you solve for y, the two equations that you get are actually going to be exactly the same. Here I have y equals 3x plus 2. If you take this bottom equation and solve for y by dividing by 2 on both sides, you're going to get the exact same thing as the top equation. So really these two equations are exactly the same. So when you graph it and they're dependent, that means that you've got one line and you've got a second line that's right on top of the first line. So the lines are actually overlapping. If the lines are overlapping like that, then where do they cross? They cross everywhere, thus infinite solutions. Alright? Or they could be, the system could be inconsistent. If the system is inconsistent, that means it has no solution. If it's inconsistent, there's no solution, that actually means the lines are parallel. They're going to have exactly the same slope. So here you see a 3 and a 3, they have exactly the same slope, but they have different y-intercepts. So in order for it to be inconsistent, you need the same slope, different intercepts. Alright, and when that happens, you're going to get two parallel lines. So, when we're graphing systems, one of those three things is going to happen, and you can tell what's going to happen before you graph it. You can tell by looking at the equations. Are there different slopes? Are they the exact same equation? Or are they the same slope with different intercepts? So depending on what you've got there, you can know what the graph is going to look like actually before you graph it. Let's look at an example of graphing these. Okay, so in this example, we are asked to solve this system of equations. Alright? In order to solve, the first step is for me to take each of these equations separately and put it into the correct form. It needs to be in y equals mx plus b, slope-intercept form. So the first step is to solve for y. So let's do the first equation. First step to solve for y, subtract that 2x to the other side. And then, to get the y by itself, we're going to need to divide by 3. That gives us... Alright, now we take the second equation and solve it for y. Add 3x to the other side, and divide by 4. 10 over 4 reduces to 5 over 2. Alright, now that we've solved, you can either graph it by hand or you can put them in your calculator. I know most of you guys would probably prefer calculator, and that's what we're going to focus on in class, learning how to do that on our TI Inspires. But right now I'm going to go ahead and graph it by hand using good old y equals mx plus b. So when I look at this first equation, it looks like my y-intercept, the b part, is 1/3. So I need to come to 1/3 on my y-axis. I'd say that's about there. And then we need to rise -2 and run 3. So come down to over 3. Alright, and when I connect those 2 points, that's going to be my first line. Alright, now let's come down and graph the second line. When I graph this one, it looks like my y-intercept is 5/2. 5/2 is 2.5, 2.5, -2.5. So I need to come down -2.5. Looks like that's about here. And then my slope is 3/4. So I need to rise 3, run 4. So from here we're going to go up 3, over 4. Looks like that's about right here. Alright, and then we connect those 2 points to get our second line. The place where the 2 lines cross is our answer. And looks like that point is at -1, 2. Alright, so the answer is -1, 2. Great.